So first off, we're going to go over the moles enrichment. So let me share screen. Go. So that my online students can see what problems you were doing. Now, these are the problems that we did. So if you're watching this online, I recommend pausing the recording, then trying the problems on your own, and then once you're ready, resuming the recording to see the answers. So here are problems 1 through 5. There's 6 and 7. Again, pause, try it, then resume when you're ready. And then here are 8, 9, and 10. Pause, then resume when you're ready. And then there are a couple review problems as well on formulas. So pause and then resume when you're ready. Okay. So, molar mass of aluminum nitrate. Let's see. Stop share. I wonder if there's a way I can split the screen. That'd be really nice if I could do that. I don't think there is. Okay. Oh well. So we want to do molar mass of aluminum nitrate, right? Oops, wrong one. Aluminum nitrate, yes. So I think what I'll do is I'll just zoom it way in, and then I can just write on the board. There we go. All right. Using that doctorate for something important, right? Okay, first of all, you need to know the formula for aluminum nitrate, right? What's the formula for aluminum nitrate? Aluminum is Al plus 3, and what's nitrate? NO3 minus, right? So the formula ends up being AlNO3, what? 3, right? So that means that when we're calculating the molar mass, we need the mass of aluminum plus, we have to distribute this 3. Plus, so there's 1. For nitrogen, there are 3, and for oxygen, there are how many? 3 times 3? 9, right? Okay, so you have to distribute this 3 just like in that, right? 3 times 1 is 3, 3 times 3 is 9, and then there's just 1 aluminum. Now we need our periodic table. So let me find one paper base that's easier to carry around. Just open up my textbook. Aluminum's molar mass is 26.98. Nitrogen is what? 14.00 something. And oxygen is 16. So we have to do a little bit of arithmetic. So this is 26.98. What's 3 times 14? Oops, 3 times 14, right? 126, and 9 times 16, 144. Do we agree? So now we just add them up. Oh, correct. 26.98 plus 126 plus 144. I got 296.98. My units are grams per mole. Did you? Yes, no, maybe? Do I need to double check my arithmetic? 3 times 14 is 42. Wow. I will blame a certain someone for that who is unbeknownst to our eyes right now, if you catch my drift. Certain phases of our lives make us a little bit dumber than others. Do we get 202.98? Now, do we agree? All right. So, any questions on this one? Other than the fact that I can't multiply. Okay, so we've already calculated the molar mass, so we don't have to calculate it again. Woo-hoo. Because the problem now asks how many moles are in 2 grams. Okay, anytime you see grams, you need to think to yourself, definitely not using Avogadro's number, right? Because if we're doing a calculation involving grams, that means molar mass, right? Not Avogadro's number. So if I've got 2 grams times, we're going to make a conversion factor. We want grams to go away, and we want moles to be what we're left with, right? 1 mole has a mass of how many grams? What we just calculated, 212.98. So 2 times 1 divided by 212.98. So in other words, 2 divided by 212.98. Try that again, just to make sure. 2 on 2.98. Yep, got the same answer again. So that gives me 0.00939, which we would write in scientific notation as 9.39 times 10 to the negative, how many? 1, 2, 3. But this is still too many sig figs, right? I have 2 sig figs in my original, so I need to round that to 9.4 times 10 to the negative 3. And my unit would be moles. No, but I would prefer that you do. If you've got more than 1 0 in front, I'd prefer it be scientific. Questions about 1 or 2? All right, let's go on to 3. Oops, too high. All right, what's the molar mass of magnesium chloride? So first thing you need is the formula for magnesium chloride, right? You can't do this without the formula. Magnesium chloride has the formula, well, let's figure it out. Mg2 plus Cl minus gives me MgCl2, right? Do we agree? Do we agree? So magnesium, there's 1, and chlorine, there are 2. 35.45, and magnesium is 24.305. Right, 305. All right, so when we add those together, 24.305, I came up with 95.205 grams per mole. Did you? All right, now we've got another question. Grams converting to moles. So 11.9 grams. We're converting it to moles. That means moles goes on top and grams are on bottom. So the molar mass is what goes with grams, right? 1 mole has a mass of 95.205 grams. So 11.9 divided by 95.205 gives me 0.12499. My calculator spits out. I obviously can't keep all those sig figs, right? I can only keep 3. So that would be 0.125, and my unit would be moles. Do we agree here? All right, let's move up. Okay, it's just asking how many molecules. All right, so number, whatever this is, 5 is asking for molecules from grams. Is that something I can do in one calculation? Nope, it's not. It's a 2-step problem, right? Because I can't go straight from grams to molecules. That's not something I'm able to do. I have to go from grams to moles, then moles to molecules. But the first thing I need to do is I need to calculate its molar mass. But before I can do that, I need to know its formula, right? This is Cu2 plus. This is PO4 3 minus. So when I crisscross those, I get Cu3 PO4 2. Do we agree for that formula? And so its molar mass would be 3 times copper. It would be 2 times 1, 2 phosphorus, 2 times 4, 8 oxygen. So oxygen is 16, I don't remember the decimal places for phosphorus, 30.974. I don't remember the decimal places for copper, 63.546. All right, so 3 times 63.546, that gives me 190.638. 2 times 30.974, that gives me 61.948. And then 8 times 16 gives me 128. So my total molar mass plus 190.638. Do we agree 380.59 grams per mole? All right, now this is a two-step problem, right? So we're going to go grams to moles and then moles to molecules. Okay, so 11.21 grams times 380.59 grams per mole. Okay, grams cancels. So 11.21 divided by 380.59 gives me 0.02945 moles. That's great, but I'm not done yet, right? Because the problem asks how many molecules. So what do I use for this conversion factor? 1 mole is equal to how many molecules? Avogadro's number, right? 6.022 times 10 to the 23rd molecules per mole. So times 6.022 to the 23rd gives me 1.774 times 10 to the 22nd molecules. Do we agree on this one? Yes? Yes. Okay, let's go ahead and do this one. Molar mass of water is about 18, so we can do this one pretty easily. So 13.4 grams times 18 grams per mole. I'm just rounding, right? So 13.4 divided by 18. That gives me 0.7444 moles times Avogadro's number, molecules per 1 mole. So times 6.022 to the 23rd. That gives me 4.48 times 10 to the 23rd molecules. When you calculate number of molecules, if you get a big giant number like that, is that reasonable? Is that a reasonable answer to get a huge number for molecules? Yes, it is. Is it reasonable to get a big huge number like this for grams or moles? No, it's not. So you can always check your work, okay? Because if your answer is humongous and its number of molecules, no big deal. If your answer is humongous and its number of grams, you've probably used Avogadro's number when you shouldn't have, okay? So that's always a nice self-check. Avogadro's number should give you a massive answer. And if you're doing a calculation involving number of atoms or number of particles, it makes sense that your answer would be humongous. However, if your answer is teeny, teeny, tiny, like 10 to the negative 30th for a number of molecules, you know you've done a conversion factor backwards, upside down. So that should always be something that you use to kind of self-check there. Okay, 1.28 moles, how many grams? That's fine. Calcium fluoride, Ca2 plus, F minus gives us CaF2. Okay, so you've got 1.28 moles, and I want to know how many grams. So do I use Avogadro's number or molar mass? Which one do I use? Molar mass, right. So I need to calculate that, right? 1 times and fluorine 2 times. Calcium's 40-something, 40.078. And fluorine, 18.998. Now the decimal places vary on the periodic table that you're using. So 18.998 times 2 plus 40.078. I got 78.074. Do we agree? All right, so let's do our conversion. 1.28 moles. Now it's different, right? Does moles go on top or on bottom? This time moles goes on bottom, right? 1 mole has a mass of 78.074 grams, right? Because we want moles to cancel, moles goes on bottom. So times 1.28 gives me, my calculator spits out 99.9347. My calculator doesn't know anything about sig figs, right? I need to keep 3 significant figures. How do I round this number to 3 significant figures? Right? If this were 99.95 or higher, we'd write it as 100 point with a decimal place, right? But because this is 99.3, we'd round it to 99.9. And my units will be grams. Okay? So just keep in mind, if this number were 5 or higher, you'd write it as 100 with a decimal place. But because it's less than 5, we're writing it as 99.9. And is that a reasonable unit for number of grams? Yes. If it were 99.9 times 10 to the 50th, that's not a reasonable number of grams. Okay. Next problem. A container holds 1.5 times 10 to the 20th molecules. How many moles is this? Okay, so we're going from molecules to moles. Do we use molar mass or Avogadro's number? Which one? Avogadro's number, right? There's nothing about grams in here. I don't ask what quantity is this in grams, right? It's just Avogadro's number. So we'd write 1.50 times 10 to the 20th molecules. Molecules goes on bottom, right? And there are 6.022 times 10 to the 23rd molecules for 1 mole. So we're just dividing 1.5 times 10 to the 20th divided by 6.022 times 10 to the 23rd. When I gave back some of your papers that I was looking at, I saw a couple of you multiplied instead of divided because I saw some 10 to the 40th answers, right? The answer here would be 0.000249, which we would then write as 2.49 times 10 to the negative 4th, right? Moles. On a couple of your papers I handed back when I was just glancing at them, because I just checked it to make sure that you did it and you showed your work. If you did that, you got the points. I saw some of you had answers to like 10 to the 40th. What happened here is you multiplied instead of divided. You had your conversion upside down. Right? 10 to the 40th is not a reasonable number of moles. It's a reasonable number of molecules. It's not a reasonable number of moles. You made a mistake on this one. Do you see where you made it? Yes. Okay. It looks like I've chopped off part of the question here. 120 grams of CHCl3, which should be trichloromethane, are in a sealed container. How many moles do you have? Okay, we're going from grams to moles. Do you use Avogadro's number or molar mass? We need molar mass, right? We're going from grams to moles here. So we need molar mass. So carbon, 1 times 12.011. Hydrogen, 1 times 1.008. And chlorine, 3 times 35.45? Yes, I think. Chlorine. 35.45, yep. Okay, so all right, so I got 119.369. Do we agree? Okay, so 120 grams, no decimal place there, notice. That's important for sig figs because if there's no decimal here, is that 0 significant? No, it's not. This number only has 2 sig figs. We're converting grams to moles, so 119.369 grams in every 1 mole. So 120 divided by 119.369. My calculator spits out 1.00528. I can't keep all those decimal places though, right? So what's the answer? It would be what? What's the answer to 2 sig figs? 1.0, right. And my unit would be moles. Okay, so this next one becomes extremely easy, right? Because you know 1 mole is equal to how many molecules? Right, so this would be 6.022 times 10 to the 23rd. I mean, you could do the conversion, right? 1.0 moles times 6.022 times 10 to the 23rd molecules per mole. And that'll give you that answer. Right? So if you just wrote Avogadro's number there, I would accept it because I would assume that you knew that that meant 1 mole is equal to 6.022 times 10 to the 23rd. Questions on this one? Okay. You have 4.32 times 10 to the 24th molecules of benzene, which is C6H6. What is the mass in grams? Okay, can you go straight from molecules to grams? Is that a 1-step calculation? Molecules to grams, is that 1 step? Nope, that's 2 steps, right? So what do? You go molecules to what first? Molecules to moles, and then moles to grams. All right, so let's do step 1. 4.32 times 10 to the 24th molecules. How many molecules are in a mole? That'll be Avogadro's number. All right, molecules cancels. We're left with moles. So 4.32 times 10 to the 24th divided by 6.022 times 10 to the 23rd gives me 7.174 times, oops, nothing, just 7.174. Do we agree? Now we've got to convert moles to grams. So what do I need to do that? I need something to convert moles to grams. What do I use? What is it? Molar mass, right? Molar mass would be 6 times 12.011 plus 6 times 1.008. So 6 times 12.011 plus 6 times 1.008. I got 78.114. Do we agree on that molar mass? All right, now we convert moles to grams. So 1 mole has a mass of 78.114 grams. Moles cancels. So times 7.174. And now we keep 3 significant figures because I had 3 significant figures in my final answer. 7.174 times 78.114. So that gives me 560 with a decimal place grams. Do we agree? Because my calculator spits out 560.3898. Da, 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 da. If I'm keeping 3 sig figs, I need that decimal. Do we agree? Yes? Yes? All right, let's go through these review problems real quick. No calculator needed there. All right. Aluminum metal reacts with cobalt-2 bromide. When you see the word metal, does that mean ion or not ion? Is there a charge on the aluminum metal? No, it's just straight up Al. And cobalt-2 bromide, that 2 tells me it's CO plus 2. Bromide is Br minus. So what's the formula? CO Br what? 2. Okay. What kind of reaction is that? Single displacement, right? So that means that the metal becomes the new cation. So it's going to become Al3 plus. And it's going to get together with whatever that anion is. Right, so that would be AlBr3. And whatever the cation was gets kicked out as the metal. Remember, the metal has no charge. No charge. Is this balanced? Is this balanced? No. You need a 2 here, and a 3 here, and a 2 here, and a 3 here. Right? And this is single displacement. Don't forget the displacement part, right? A lot of you on lab just wrote single or double, right? Not single or double, single displacement or double displacement. Questions on this one? Questions on this one? All right, let's do the next one. Boy, I'm just getting like bombarded with emails. Okay, calcium carbonate. So calcium is Ca2 plus, carbonate is CO3 2 minus, so this is CaCO3. And sodium hydroxide will be Na plus and OH minus. Right, so that's just NaOH. What kind of reaction is this? Double displacement, right? So that means that calcium, Ca2 plus, is going to get with hydroxide. Right, so that gives me CaOH2. And that means Na plus is going to get together with carbonate, CO3 2 minus. So that gives me Na2CO3. Is this balanced? No. No. What do I need?
2 on the NaOH.
Just the 2 in front of NaOH. Right. Double displacement. Questions on this one? All right. And then there's just last one, right? Combustion of octane. Okay, octane is C8H18. Combustion, what does that entail? O2 is a reactant. Is this combustion of a metal or combustion of a hydrocarbon?
Hydrocarbon.
This is a hydrocarbon, right? So what are we going to produce?
CO2 and H2O.
CO2 and H2O. Let's make a reactant product table for this one because these are the kind that students have lots of trouble with. Carbon, hydrogen, oxygen. 8, 18, 2. Carbon, hydrogen, oxygen. 1, 2 plus 1 and 2. All right, let's balance carbon with an 8. Oops, wrong place. With an 8. And distribute it to 8 times 1 is 8. 8 times 2 is 16. All right, now let's balance hydrogen. We need 9 here, right? 9 times 2 is 18. And 9 times 1 is 9. All right, now we've got a problem here because this adds up to 25. Is 25 a multiple of 2? No. So what do? I say to myself, okay, 2x equals 25, so x must be 25 halves. So if I put a coefficient of 25 halves here, that makes this 25. But are you going to have 25 halves of a molecule? No. So how do I get rid of that? Multiply everybody by the denominator. Okay, so what does that do? That makes this coefficient become 2. That makes this coefficient become 25. That makes this coefficient become 16. That makes this coefficient become 18. And that's my final answer. We're not going to get to the stoichiometry enrichment today, so we'll go over it at the very beginning of class on Monday. So we'll stop here for today. And yes, on Friday, we will have our quiz on Monday instead. So we'll go over the enrichment, then we'll take our quiz. Sounds good?